All right, let's talk about wave period and frequency. All right. So before we actually talk about waves, let's talk about something related to waves. And that is an object spinning in a circle. Okay? So we're interested in this object right here, and we're going to imagine that this is like, say, a planet going around the sun, all right? Or a point on a record as the record player turns round and round, and we're watching it, okay? So what we might be interested in is we might be interested in the time it takes for this to go once around. So if this is the Earth and this is the Sun, the time it takes for the Earth to go once around the Sun is 365 days, or 365.25 if you want to get technical. So we call this the period. If it's a record, I don't know the exact time it takes, but I'm going to say it's like 1 second, say, something like that. So period, ooh, I don't like that color. So period equals the time for one cycle. Okay? So a cycle is going around here one time. Okay? Where else do we see period and cycle? Well, imagine if we have a pendulum, right? We have a string with a heavy weight on it, or even like a swing set, right, down at your local playground. It swings back and forth. And we might find that this thing swings back and forth and back and forth. Okay? So we would say that one cycle has been completed when the pendulum goes all the way there and comes all the way back. So the period for a pendulum equals, again, the time for one cycle. Okay? Or, like we said, this could be you down at the playground, you know, swinging away. You know, I'm swinging. Okay? Riding on the swing. And with a wave, it's a similar idea. Okay? And actually, one way to kind of imagine a wave is to think about what would happen if we kind of had a pendulum sort of swinging, or maybe a different kind of pendulum. Let's imagine the pendulum is like a ball on a spring, right? It's going to kind of spring up and down and up and down and up and down and up and down, right? Now let's imagine that we were to put a pen on here, right? Or a marker. And as this thing springs up and down, we rolled paper past it, right? So let's imagine we have like a big roll of paper. And the roll of paper is like doing this, and this guy's like springing up and down. It's got a pen on it. Well, what would you see written out on the paper as this thing springed up and down, do you think? And you would likely see this kind of a thing. Now, from math class, you might call this a sine or a cosine wave, depending on where you start it, right? You got to study that in math, sine functions and so on. It doesn't really matter if you do or you don't. The point here is that if this thing is going up and down, we can almost say this is like one of those particles in our medium that's going up and down as a wave goes by, right? And so what we could say is then, one period is equal to the time that it takes for this to go down, down, up, up. So in other words, the period when we're talking about a wave is just simply the time for one cycle, and one cycle is equivalent to one wavelength. So one wavelength to go by. So it's the time for one wave to go by. Okay? So again, period is the time for one wave to go by. Okay? Often we call period T, right? Big T for time. Time, period are equal. And the symbol for period is often a large T. Okay. Now there's a related thing here, and that's called frequency. Okay? We can look at frequency in a similar way that we looked at all the other things that we have just kind of talked about. Okay? frequency equals cycles every second. So how many times does a wavelength go by? Or how many times does this spin around? Or how many times does this go, you know, up and down and back up again every second? Okay, so how many cycles per second do we have, right? So let's imagine this. Imagine that you have a wave train, okay, so a whole bunch of waves, a wave train moving along such that one wavelength occurs every 1/2 second. Okay, so imagine that. Let's draw that in a picture. So here's our train of waves, okay, coming by. And let's say that you are standing here and you're observing this point right here. Okay, so you're just watching what this does. And you're looking. Here you are, hands on hips. You're a very, serious observer. You're just watching what this thing does. Okay, what you will see is it's going to go up and down. Okay, it's going to go up and down every 1/2 second. Okay, so we could say then that t, the period of this wave, is equal to 0.5 seconds. It takes 1/2 second for this to go. And, or we could also say it takes 1/2 second for one wavelength to pass by. Are you with me? So now the question I'm going to ask you from this is, what is the frequency of this set of waves? What's the frequency? The period is 1/2 second. What's the frequency? So in other words, if it takes 1/2 second for one wave to go by, how many waves go by every second? 2. Perfect. Frequency equals 2. So we get 2 cycles per second. Now, frequency or cycles per second has a special name, all right? We call the cycle per second the hertz, or the hertz. So we would say that this wave has a frequency of 2 hertz, abbreviated Hz. So it's a 2 hertz wave. Okay? Now, how is period, looking at this, related to frequency? How can we convert frequency into period or period into frequency? How can we say they are related? They are what? In order to get frequency, what did we do with our value for period in order to get frequency? Here, this might help. Frequency equals waves per second. Period equals second per waves. Waves per second and second per waves are what of each other? What do we call these? Is that reciprocals? So these guys are reciprocals. So in order to convert one into the other, you just do the reciprocal. So you could say this: frequency is the reciprocal of period, and period is the reciprocal of frequency. Okay? So it's very easy to convert one into the other. Let's try it. Find the frequency. Actually, sorry, let's do it the other way. Find the period of a 10 megahertz wave. Okay, so I'm going to let you do that. T equals 1 over F. In this case, the frequency is 10 megahertz. What's a mega? What's a mega mean? Means what? A million. Perfect. 10 megahertz, so 10 times 10 to the 6 hertz. And what do we get? So, just using our sort of rules of exponents, we should get, the answer is 10 times 10 to the negative 6. The answer would be in seconds, or 1 times 10 to the negative 7 seconds.